Yeah, C34 international paper, June 2017, question 14, last question on the paper. We've got a diagram, shows the curve C with parametric equations, x equals that, y equals that, all between 0 and pi over 2. Point P lies in C, has got parameter theta equals pi over 3. We're going to find the coordinates of P and show the equation of the normal is equal to this. So theta is pi over 3, sticking pi over 3 into the x1, I'll have 8 times cos pi over 3 all cubed. Cos pi over 3 is a half, so this is just equal to 1. Put it into the y, I'll have 6 times sine pi over 3 all squared. Sine pi over 3 is a half. So that gives us 9 over 2, or 4.5, so it's the coordinates of P are 1, 4.5. Then part B, line L is the normal to C at P. So we need to find the gradient of the graph at P. So dy by dx, parametric though, so I need to do dy over d theta over dx over d theta, differentiate the y and the x in terms of thetas. The y differentiated, well, the 2 is going to go in front. So I've sine theta to the power of 1 multiplied by the sine theta differentiated, which is cos theta. So I'll have 12 sine theta cos theta. The x differentiated, the 3 will go in front again, which gives me 24. I'll have cos squared, then I'll need to multiply by minus sine, because that's what cos theta is differentiated. So I'll have minus 24 cos squared sine theta. I can do a bit of cancelling, get rid of the sines, and a cos off the top and the bottom, and the 12 and the 24. It's going to be 2, so it's actually minus 1 over 2 cos theta. The cos pi over 3, remember, was a half, so this turns out to be minus 1. So that's the gradient of the graph P. Gradient of the normal is going to be 1 then, negative reciprocal, which means the equation of the line using the 1 and 4.5, I get y equals x plus 3.5. Then it said show the area of S is given by this 4 plus that integral, and then find the exact area. So I'm going to split into 2 parts because I need the area under the curve and this trapezium. A little bit about the graph. Just here, theta is equal to 0. The x is going to be just 8. And of course, the y is going to be 0 because sine 0 is 0. Here, the x value is 1. Just here, theta is equal to theta pi over 3. And at the top then, so we've got theta 0, theta pi over 3, and theta pi over 2 up here, because the x is going to be 0 this time, because the cos of pi over 2 is 0, and sine of pi over 2 is 1, so the y value there is just 6. That's 3.5 there, where the graph, the y-axis was the plus c on the y equals mx plus c. Area under the curve then. I need to integrate y dx, but it's parametric, so I'm going to write it as y times dx over d theta. So I'm going to integrate y times the x differentiated. Now I'm going to integrate the curve between 8 and 1, and the corresponding theta values are 0, where x is 8, and where x is 1, theta was pi over 3. So the y then is just the 6 sine squared. The dx over d theta, we did that before when we differentiated the curve. It was minus 24 cos squared sine theta, and then with the d theta in front. I've got to get it into this form. So I'm going to take out the minus 144. I've got sine cubed cos squared then. And I can change a sine squared here. I've got, so what I'm looking for is a sine theta something, So I've got sine cubed here, so I can change the sine squared into 1 minus cos squared. So I've got sine theta times sine squared here, really. And then it started to look a bit like this now, because I've got sine theta and then just coses. And what I can do with this, because I've got 0 at the top and pi over 3 at the bottom and a minus in front, I can change it to plus 144 and swap over the limits, because this one I do that one minus that one, which is the same as doing minus this, take away this. and inside the integral I've got sine times 1 times cos squared, which is this, and sine times minus cos squared times cos squared, which is that. The 4 is the area of the trapezium, so I'll just do 3.5 out of the parallel sides, 3.5 plus 4.5, divide that by 2 and multiply by 1. You'll need to show that because it's a show question. They'll need to see that sum somewhere. So the total area is what they say it is. And then find the exact area of S. Well, we need to do this integration. So we'll do 4 plus 144. Now, if I need to differentiate something to give me this, to reverse the chain rule really, if I differentiate cos cubed, the 3 will go in front, and then I'll have cos squared multiplied by minus sine, but I don't want the minus, I don't want the 3 in front, so I have to multiply by minus a third. For this term, if I differentiate cos to the power of 5, the 5 will go in front, I'll have cos to the power of 4 multiplied by minus sine. So I've got minus sign here, but I don't want the 5, so I'll have to multiply by a fifth. Put the limits in, putting pi over 3 into this, I'll get minus 1 over 24 plus 160, and then putting 0 in, cos 0 is just 1, so it's just minus a third plus a fifth, and that gives me 181 over 10.